In close quarters combat, survival is determined in fractions of a second. If a rifleman misses a target, life depends on the next reload. For a German soldier with a Kar 98K, that meant manually yanking a steel bolt back and shoving it forward for every single shot. An American rifleman with an M1 Garand only had to pull the trigger again. A trained shooter could deliver roughly 10 to 15 rounds per minute, a rhythm dictated by the physical movement of the arm. The dats between these pulses are seconds of vulnerability where the soldier is effectively unarmed, providing a charging enemy a clear window. By the middle of the war, the ability to hit a target at long range was outweighed by the sheer volume of fire a soldier could generate in seconds. The M1 Garand gave the American infantrymen the ability to fire 8 rounds as fast as they could pull the trigger. It changed the nature of the firefight, putting Axis bolt-action units at a severe disadvantage. This photograph shows the industrial scale required to maintain that advantage. American factories were built to produce these high-precision weapons by the millions. An infantry squad now possessed double the individual rate of fire compared to their counterparts, allowing them to suppress enemy positions more effectively. German commanders realized their industrial base could not outproduce the United States in a rifle-for-rifle competition. The M1 Garand demonstrated that industrial capacity could dictate battlefield outcomes, forcing Germany to look toward different engineering solutions. To counter the American advantage, Germany shifted its tactical focus away from standard rifles and toward squad-level machine guns like the MG42. Instead of relying on slow machining and expensive steel, engineers designed the MG42 to be built from cheap stamped metal parts and electric welding, reducing production costs by up to 50% compared to earlier models. This chart compares the rate of fire across the standard infantry kit. The Garand was fast, but the MG42 fired 1,200 rounds per minute, suppressing American squads. Because of efficient manufacturing, Germany produced over 400,000 units, despite severe resource shortages. The MG42 proved that a design optimized for mass production could achieve battlefield dominance through overwhelming suppressive fire. Heavy machine guns like the MG42 provided massive firepower, but they were static. To fire accurately, they required a tripod or a bipod, meaning they couldn't be used effectively while a squad was moving forward. This led to hybrid weapons like the American BAR and German FG42, attempts to place machine gun rates of fire into a portable rifle frame. This schematic shows the physics limiting these hybrids. Firing full-power sniper ammunition from a light frame on automatic generated an uncontrollable upward recoil. As the barrel jerked upward, bullets scattered wildly, and the violent vibration often damaged the gun's internal mechanisms. To successfully combine the accuracy of a rifle with the speed of a machine gun, engineers realized they had to change the ammunition itself. The result of that realization was the Sturmgewehr 44. It successfully bridged the gap between a bolt-action rifle and a machine gun. Instead of focusing on the rifle's mechanical components, engineers redesigned the cartridge itself, creating the 7.92 by 33 mm Kurz. This comparison shows the difference. Using a smaller casing with less gunpowder produced significantly less kinetic recoil. With recoil now controllable, a soldier could fire accurately at 300 meters or switch to full auto to suppress enemies on the move. The STG-44 ended the search for a mobile, rapid-fire infantry arm, creating a weapon that outclassed all previous designs in terms of tactical utility. The shift toward automatic fire meant that heavy bolt-action rifles could no longer meet the requirements of a high rate of fire battlefield. While the STG-44 arrived too late to change the war, it provided the design template for nearly every assault rifle in use today. The lessons learned from the MG42 also survived, influencing the engineering of the American M60 and the move toward mass-produced high-output machine guns. Today, the engineering DNA of these weapons is standard in every modern military, as squads prioritize putting high volumes of lead downrange. The deadliest conflict in history proved that infantry effectiveness isn't a product of individual marksmanship alone. It is a calculation of relentless engineering and the math of rounds per minute. Subscribe for more of our in-depth engineering history.